All right, so we kind of finished talking about similarity in triangles in the notes yesterday, kind of a warm-up of foreshadowing. Now we're going to go in depth in it now. All right, so some key concepts is corresponding lengths and similar polygons. So I'm right here. If two polygons are similar, then the ratio of any two corresponding lengths of the polygons is equal to the scale factor of the similar polygons. All right. So we're going to elaborate on that. And another thing is, one way you can determine if two figures are similar is to verify that all corresponding angles are congruent. So I started this before the bell rang, I'm sorry. And all corresponding pairs of sides are proportional. So this is what it means. We're going to do this example right here. We're going to find the scale factor. All right. So we're going to match up corresponding sides. So we'll go this way, where this is the pre-image and this is the final image. So the scale factor right here. Actually, let's go in reverse because I just read the directions. All right. So we'll make it a reduction. We're getting smaller reduction. And the scale factor is just, if this is the pre-image, this is the final image. Well, remember we want the final length, so 20 over 25, and it reduces to 4/5. In fact, if I pick any corresponding side lengths like 16 and 20, if I do 16 divided by 20, notice how again I get 4/5. I should get 4/5 no matter which side I pick. If I pick 12 and 15, 12 divided by 15, 4/5. So on and so forth. And this last one, 24 and 30, 24 divided by. So notice how the ratio of corresponding sides equal each other. So that's great. And then we'll just kind of write this as a side note. All angles, all corresponding angles are congruent. All right. Now, cruising right along, here's a good logic question. Are congruent figures also similar? Explain your answer using the definition of similarity. All right, so the answer is yes. Why? Congruent figures have congruent angles. All right, that's just by definition. So the angles are congruent just like in similarity. But what about the ratio of corresponding sides? All right. So are they proportional? Well, yes, sides are proportional. All right, and what's the scale factor? The scale factor is just 1. All right. If you notice for like an enlargement, when the scale factor is bigger than 1, or for an enlargement, scale factor is bigger than 1. For a reduction, the scale factor is less than 1. But for just the same, stay the same exact, scale factor is 1. Sides are still proportional. Thus, all congruent figures are similar. Not all similar figures are congruent, though. The converse of that statement is not true. But nonetheless, let's progress. All right. In the diagram, triangle TPR is congruent to triangle XPZ. Find the length of the altitude PS. So altitude, just a fancy word for height. We can think of height H, like this right here. That's the height. That's the height. So there's a couple ways to do it. We can look at the whole base or just a proportional side. So I'm going to let's just look at the whole side while we're at it. We'll say, well, 16. Let's do this. 16 is the base. 20 is the height. So I can say the base over height. That's what I want my ratios to be, the base over the height. Well, in this triangle on the right-hand side, the base is 16, the height is 20. What about this triangle on the left-hand side? Well, the base over here is 12. And what's the height? It's unknown. All right, so we practiced this a little bit the other day, but this is when cross multiplying is going to come into play. We just want to be really good at cross multiplying. All right, technically I can reduce 16 over 20. That's okay. Or I can just immediately start and do 16 times h equals 240. All right, cool. Now, divide both sides by 16, and I believe, I'm going to double check, I believe it should be 15. Sweet, I did it right. All right, so set up we want to stay organized, like the base was on top each and every time. The height was on the bottom each and every time in our fractions. Then just cross multiply, keep our work organized, and bada bing, bada boom. All right. So again, what's the scale factor of QRST to ABCD? So we're going this way. We're starting at QRST, going to ABCD. And notice how the corresponding sides are just doubling each and every time. 8 to 4. Or 6 to 12. Or 5 to 10. So what is the scale factor? We're enlarging by 2. Now, to find x, we just have to stay organized. Like, look at this. I can say the left side and the right side. So my fraction is going to be the left side of the quadrilateral divided by the right side of the quadrilateral. What do I mean by this? Well, the left side is 10, the right side is x. So I'm going to write 10 over x. And this is going to equal in the other one, 5 over 4. Left is 5, right is 4. Now, what's important is that we just keep our work organized. Like I could say right over left. I could have done x over 10 equals 4 over 5. That's legal. I could have just said left over left. What do I mean by that? I could have said 10 over 5, because those are the left sides of both of them, equals the right sides over both of them. All right? There's a lot of ways to go about this, but it doesn't matter in any one. I'll just do this bottom one because I have the most room next to it. Just as long as you set up a correct proportion and correctly cross multiply, keep your work organized, you should get, in this particular one, x equals 8 each and every single time. All right? In phase 2, we're going to look at